In this video, we're going to work our way through illustrative mathematics, Algebra 1, Unit 2, Linear Equations, Inequalities, and Systems. In particular, Lesson 18, Representing Situations with Inequalities. So our learning goals for this video are, let's use inequalities to represent constraints in situations. So our warm-up, match inequality to the meaning of a symbol within it. A, we have h greater than 50. B, we have h less than or equal to 20. And we have C, 30 is greater than or equal to h. And think about these situations. Is 25 a solution to any of these inequalities? Which one? Is 40 a solution to any of these inequalities? Which ones? And is 30 a solution to any of these inequalities? Which ones? Take a moment and think through your solution, and then we'll go over it. So hopefully you've had time to think through your answers. So the first symbol, we have h greater than 30. So that's just this second, the middle one. H less than or equal to 20. That's this situation here. And then we have greater than or equal to, that's the last one. So it's 25 a solution to any of these inequalities. So in other words, we're just going to plug 25. So if we plug in 25 for A, is 25 greater than 50? So that's what that says. 25 greater than 50, that's false. So A doesn't work. Is 25 less than or equal to 20? That's also false. And is 30 greater than or equal to 25? That's true. So this situation works for C. Is 40 a solution to any of these inequalities? So plug in for the first one, 40 greater than 50. That's false. I'm going to put a line there. That's false. 40 is less than or equal to 20. Again, I'm going to put a line there. That's false. And then 30 greater than or equal to 40. Again, that's false. So none of these work for this one. And is 30 a solution to any of these inequalities? Which ones? So the first one will be 30 greater than 50. That's false. 30 less than or equal to 20. That's false. And 30 greater than or equal to 30. That's true because 30 does equal 30. So C does work since 30 does equal 30. How do you know whether each of these numbers, the 50, the 20, and 30, is a solution to the inequality? H equals 50, H equals 20, and 30 equals H. Beyond the different symbols, how are these equations different from inequalities in one variable? So those are some things we can think about. In addition to the questions for the warm-up. So if, in other words, to know whether they're a solution to inequality, just plug them in. And beyond the different symbols, how are these equations different from the inequalities in one variable? So these are equations using equal sign. Whereas inequalities use greater than or less than signs. Playing the senior ball. Seniors in a student council of high school are trying to come up with a budget for the senior ball. Here's some information they have gathered. Last year, 120 people attended. A success and expected to bring be even bigger this year. Anywhere up to 200 people might attend. There needs to be at least one chaperone for every 20 students. The ticket price cannot exceed $20 per person. The revenue from ticket sales needs to cover the cost of the meals and the entertainment, and also make a profit of at least $200 to be contributed to the school. Here are some inequalities the seniors wrote about the situation. Each letter stands for one inequality in the situation. Determine what is meant by each letter. So the first one, you have t less than 20. What does that mean? So the t, if we go back to our previous slide, there needs to be at least one chaperone for every 20 students. That doesn't really make sense. The ticket price cannot exceed $20 per person. That kind of makes more sense. So T is your ticket price. The next one, 120 is less than P, which is less than 200. If we look at our previous slide, last year between 120 people attended as a success. I expect to be even bigger this year, so anywhere up to 200 people might attend. So, what does that inequality represent? That's going to represent that between 120 and 200 people will attend. Amount of people to attend this year. PT minus M is greater than 200. This means the total amount collected from ticket sales. So PT, let's just make sense of that. Is the cost from ticket sales, or amount from ticket sales, and M is the cost of meals. And then last, we have C greater than P over 20. That means the number of chaperones. C, so C is your chaperones. And P, again, is the number of students attending. How many chaperones are needed if there are 120 students? So we use that chaperones inequality. So C greater than or equal to 120 over 20. So P equals 120. So 120 divided by 20. So C greater than or equal to 120 divided by 20 is going to be 6. So that means there needs to be at least 6 chaperones if there's 120 students. Elevator constraints. An elevator car in a skyscraper can hold at most 15 people. For safety reasons, each car can carry a maximum of 1,500 kilograms. On average, an adult weighs 70 kilograms and a child weighs 35 kilograms. Assume that each person carries 4 kilograms of weight with them. So for part 1, write as many equations and inequalities as you can think of to represent the constraints in the situation. Be sure to specify the means. Avoid using the letters Z, M, or G. So you might want to say something like P is less than or equal to 15. A plus C is less than or equal to 15. Where A would be adults. C equal children. In this one, the P represents people. You could say W is less than or equal to 1500. Where W equals weight. And one more, we could say W equals 70. W equals 70A plus 35C plus 4A plus 4C. So the 70A represents adult weight, the 35 represents the child's weight. That's where we're getting this from. And then each person carries 4 kilograms of gear. So that represents the weight of all the people. Trade your work with a partner. Read each other's equations and inequalities. Explain to your partner what you think their statements mean. Listen to their inequalities and their explanation of yours. Make adjustments to your equation and inequality so that they can be communicated more clearly. And rewrite your equations and inequalities so that they would work for a different building where an adult has at most Z people. Each car can carry a maximum of M kilograms, and each person can carry G kilograms of gear. Wrapping up our lesson, what are some advantages and disadvantages of representing constraints as inequalities? So if we think about it, the possible advantages are, compared to written words, inequalities are a simpler and quicker way to describe what is happening in a situation. It also makes it easier to see what values a certain quantity could or could not take when a constraint is written with symbols and words. Some possible disadvantages. Unless we know what the variables stand for, we can't be sure about the meaning of an inequality. If we don't recall what the symbols mean or how to read them, we can't access the information. What advice would you give a student who might just be learning to write inequalities represent constraints? What should they pay attention to? What are some potential sources of confusion or error they should look for? So some advice. Specify the meaning of each variable. Not using the same variable to represent different quantities. Making sure that the correct symbols are used to represent relationships. And using words to read each inequality to make sure that it fully represents a constraint. Our learning targets, which I hope we met through this video. I can write inequalities that represent constraints in a situation. And your cooldown activity, which we won't go over, but this is for you to think about and work out. Han has a budget of $25 to buy grapes. Write inequalities represent the number of pounds of grapes that Han can buy in each situation. Grapes that cost $1.99 per pound. Grapes that cost $2.49 per pound. And grapes that cost $C per pound. We'll see you in the next video where we talk about solutions to inequalities with one variable.